of the, sorry. Yes, this is the speaker, the second seminar. First is Dr. Dewi Sartiami, who speak about the edification of Sporopera pergiperda based on the morphological aspects. And also Dr. Hari Sutrisno speak about edification of Pergiperda silvoptera based on the molecular aspect. And then Professor Andi Trisyono from the Gadjah Mada University, he explained to us what we can do after the infestation of Pergiperda Indonesia. And then the third virtual seminar we conducted at the August 2020. We have the 3 speakers also here, and then we focus to discuss about the strategy to control these insects. The speaker, Dr. Pati from the PEI, we speak the mating disruptions, and Dr. Sinipas Parmi from the Bayer Crop Science, he explained what transgenic corn, and Mr. Gunawan Sutio from Prima Agrotech company, he speak about the biological insecticide for controlling of the Sporopera pergiperda. And then on September 4th, we have the 3 also speaker here. First is Professor Dr. Ichi Diana Daud from the Hasanuddin University. The topic is biological control. And then Mr. Joko Priyono from IPB. The topic is botanical insecticide. And Dr. Aras Melin from the Ministry of Agriculture. She speak about the chemical insecticide or synthetic insecticide to control the Sporopera pergiperda. And in this morning, this is the 5th virtual seminar. We present for speaker who will discuss the current situation and global action by Dr. Buyung from the FFO, and also lesson learned from our colleagues from India and also from the Korte Agri Science as the corn seed industries in Indonesia. Thank you to all speakers, Dr. Buyung, Dr. Govin Gujar, Dr. Bhagirat Chaudhry, and Mr. Aditya Bagus Wadiawan for your time and to share your knowledge, information, and also experience. So it might be one of our reference in Indonesia in managing the Sporopera pergiperda. I'd like to inform to all of you that this audience of our participants in this morning seminar come from the universities, research institutes, government, and also private company. Let me to special thank also to our guest from Malaysia, Dr. Salmah Yaakob, the President of Entomological Society of Malaysia, and Dr. Hang from the Ministry of Agriculture Vietnam, and then Dr. Anura Sirisena from the University of Rajarata, Sri Lanka, and of course to Professor Chris Wigus from the Chinese Academics Agriculture Sciences. Thank you very much for joining this seminar. And also thank you to Professor Hamim Sudarsono from Lampung University and also Dr. Eka Chandra from Andalas University as the moderator and master ceremony of this seminar. Last but not least, thank you to all OSI members led by Dr. Suputa, of course. Entomological Society of Indonesia gave a high appreciation for you because your time and cooperation to prepare in this seminar. So again, thank you very much. Have a nice seminar and wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Warahmatullahi wabarakatuh.
Thank you very much, Prof. Dadang. Ladies and gentlemen, we arrive at the peak of the event, presentation and discussion from an expert in their field about integrated pest management of Spodoptera frugiperda. This session will be led by Professor Dr. Hamim Sudarsono as a moderator. Professor Hamim Sudarsono is from Faculty of Agriculture, Lampung University, completed Bachelor at Bogor Agricultural University in 1982, Master degree in the University of Arkansas in 1989, doctoral degree at the University of Arkansas in 1992. Prof. Hamim, place and time is yours.
Thank you. Okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Ladies and gentlemen, my fellow entomologists, my fellow agricultural practitioner from Indonesia, Malaysia, Vietnam, Sri Lanka, and China. First of all, I would like to say hi from my hometown here in Bandar Lampung, Sumatra. I hope all of you are blessed with good health, happiness, and prosperity. And we are very fortunate today that we have four distinguished specialists who will be sharing with us their experience and insight about Spodoptera frugiperda. I would like to say also I'm very honored to represent the Entomological Society of Indonesia as your moderator for this very important seminar. And thank you, Prof. Dadang, as the chairman of the society, and also the official who have been working very hard to prepare this seminar. So today we have our speaker. The first speaker is Dr. Buyung Asmara Ratna Hadi. It is my honor to introduce Dr. Buyung as the first speaker. Dr. Buyung Hadi received his education from the Bogor Agriculture University at the Department of Plant, Pest, and Disease. He graduated his bachelor degree in 2002, and then he received his master degree in the International Horticulture Plant Disease Epidemiology at the Leibniz University, Hanover, in 2005. Also, he received his PhD in entomology in insect ecology from Auburn University in 2009. Dr. Hadi has a wide experience. His first position was as pesticide education coordinator, extension urban entomologist at South Dakota State University from 2010 to 2014. After that, he was the senior scientist entomology country representative in Cambodia. I think I lost. Okay, let me continue. Okay. Main research and professional interests of Dr. Hadi are regenerative agriculture, biodiversity in agricultural landscape, climate change, and pest dynamics, international agriculture and innovation system for poverty alleviation. Ladies and gentlemen, now we are ready for the presentation of Dr. Hadi. Please, you will have 20 minutes to present your slide. Thank you.
Thank you so much for the introduction, Prof. Hamim. And thank you so much for ASI for welcoming FAO into this forum. Good morning, all. It is indeed my pleasure to be here. Let me see. I think I just lost control over the screen. So if perhaps, right. Let me try to share my screen again. There you go. Can you see the screen?
Okay, Pak. Yeah.
Wonderful. Right. So it is my pleasure to open our time together here with a talk about fall armyworm, especially on maize, in the context of its function, its role as a transboundary pest that is of a huge interest for FAO as well. It is a big deal. Unfortunately, CABI named it as one of the top 10 transboundary plant pests and diseases affecting global food and agriculture in 2017. Originated from South America, for years been one of the more prominent noctuid pests in either North or South America, mainly on maize, but also feeding on sorghum and occasionally on plants like vegetables and also cotton. It is important because of at least 3 of its characteristics. It's prolific. It, each female moth can lay up to actually more than 1,000 eggs. It's a broad host range. I note here 80 crops because when we did our survey, these are 80 of the economic crops. But record out there showed that it's on over 200 hosts. The long distance migration potential over 500 kilometers. I mean, some of the record from North America showed that it is able, for example, to migrate from the southern part of the country all the way up across the border into Canada. Since 2016, it has somehow, quote unquote, escaped the Americas, and it was first detected in Africa. And then since then, it has spread all over the world. What you see on the left is actually an old map that we are now working to update. But this is already mid-year this year. It was already reported in places such as Australia. There was a detection of a specimen in Papua New Guinea awaiting molecular diagnostics. The graph on the right there is the number of countries that are reporting the presence of fall armyworm across the years. And you see it's linear and it hasn't abated yet. So I'm gonna start sharing some of the data that are available out there. Many of these are collected by our research partners, i.e. organizations such as ECP, CIMIT, and CABI, where we typically act as collaborators. All of those organizations sit in the Global Actions Technical Committee. So what you see here, including our data from Tanzania, there is the field scale estimate of loss. When fall armyworm was first detected in Africa, there was some ex-ante analysis that showed that yield loss can go up to 40%. The good news is that field scale estimates showed that it's actually lower than that. The bad news is that it is still substantial. So what you see there is across Africa, yield loss is typically estimated between 12 to about 23, 24%, with a median of around 16 to 18%. And if we extrapolate this median number across countries that produce maize in Africa, Asia, and the Near East, it still amount to about 80 million tons worth $18 billion per year and affecting about 600 million people. So for us, for FAO, the both the economic and the humanitarian case is clear for an intervention. FAO has been at the forefront of the action to mitigate the risks of fall armyworm spread globally since 2016, but it was done in a somewhat ad hoc fashion. And then in 2019, FAO DG decided to spearhead a global action that bring together all of the partners globally, both in the research and development spheres, so that we can have a coordinated action against this pest. So the Global Action for Fall Armyworm Control was launched in December 2019. It has a steering committee that is chaired by our DG. It has 23 members from high-level global leadership, either from donor community or from the government community, as well as private sector and research. It has a technical committee chaired by the chief scientist of USAID. It has the technical committee comprises of 7 technical working groups with over 50 members. One thing that I would like to highlight as a part of the work of the technical committee was a global IPM assessment that was done in summer 2020, and it is almost finished now, in which the technical committee members go through all of the available evidences of IPM options and sort of try to weigh the strength for different options that can later on be provided to member countries in terms of recommendations. I will touch a little bit, as this is not yet finalized, but I will touch a little bit on the preliminary results of the assessment. The objective of the global action is threefold. First one is to reduce crop yield losses to about 5%. You remember I said 16 to 18 median. We would like to reduce it to below or around 5% in the demonstration countries and about 10% in pilot countries. And I'll talk more about what I mean by demonstration and pilot countries. The second objective is to delay further spread, or at least to prepare countries in which the pest is not yet detected, so that the risk of damage can be curbed from the very beginning. And of course, the very last objective is to bring together a global coordination platform, but this is really not just global. As you can see there, there is a FAO Fall Armyworm International Steering Committee by the DG. I already mentioned that. The technical committee, the FAO HQ Secretariat, in which I serve as a technical lead, and then the 7 technical working groups. There will be regional or sub-regional, it's not called task force, actually, it's called steering groups that will be established soon, and national task forces, especially in the demonstration countries. So what do I mean by demonstration and pilot countries? The Global Action decided to, for ease of organization, to classify the world into 3 regions, Asia Pacific really, and then NENA, Near East and North Africa, and then Africa or Sub-Saharan Africa. And 8 countries were identified as the demonstration countries. As you can see here, there's China, the Philippines, and India for Asia. For NENA region, it's Egypt. And for Sub-Saharan Africa, it's Burkina Faso, Cameroon, and Kenya, and Malawi. Most of the action next year, 2021, will be focused on these demonstration countries so that they become a hub of on-the-ground evidence gathering of how different IPM options can really work and be mainstream among smallholder farmers. All of the surrounding countries around these demonstration countries are classified as pilot countries, and they will benefit through training, both in person, if it is possible, or virtual, that will be conducted in the demonstration countries. So Indonesia is definitely important for us. It's, as I understand it, one of the biggest maize producer in Southeast Asia. So there will be, we would love to collaborate further with all of you here to also work on this important action, especially through trainings and mainstreaming of IPM options that we found to be working. Let me spend a bit of time talking about what we see as the challenges and why IPM is the solution. So the data come from Africa again, mainly because, you know, since 2016, been working there. So there's a lot of data coming from Africa. And this is data that I collected by our colleagues in Kabi, as well as Kumela, I think it's either Simit or ECP, that showed that pesticide or conventional pesticide is the predominant way in which smallholder farmers choose to manage fall armyworm. The data there showed between 28 to about 82% of households in different countries reported that this is the main, if not the only way they chose to manage fall armyworm. The problem, as always, is in the details. So okay, pesticide is the main way. What kind of pesticides? Here we split the pesticides into different classes of hazards based on WHO hazard classification. And what we see there, some of the pesticides used are on 1B, which is highly hazardous. And a lot of those are actually banned, also in the countries in which we did, or they did the survey. And this is a real cause of concern, of course, globally and also for us. Most of the pesticides used are of class 2, moderately hazardous. And in and of themselves, there are risk mitigation practices, of course, at least theoretically, that can be done to reduce the human health or environmental health risks of the use of class 2 pesticides. But they also did a survey of, you know, how many households are actually using any PPEs, you know, personal protective equipments. And what the data showed is that many of the households actually use either none or very little. You know, the most that are used are gumboots, which is important, but then it doesn't reduce the exposure that comes from skin, your hand, from your eyes, from breathing the vapor and whatnot. And thus, unfortunately, this is also associated with at least 20% of the sampled households in these countries reporting at least one negative pesticide-related health syndrome. So again, for us here, the conundrum is thus. We have a pest that, if not controlled, can be a real problem for food security and for farmers' livelihood. Yet, the predominant way in which the pest is controlled is probably just as harmful as the pest itself. Thus, what's the solution? The running thinking in FAO and in the technical committee is to use this model, if you will, of IPM, in which the bottom of the pyramid are things that are done every season in a particular field. And it includes things like cultural control, host plant resistance, biological control, landscape effect, the diversity of the landscape in a particular area, and paying close attention to the pest ecology. Detection and scouting is also something that is done routinely, and pesticides, or in this case, insecticides, are not supposed to be something that is done every season or multiple times in a season. It is done according to a guide, and if all of these activities in the bottom part of the pyramid is done right, the belief is, and actually the evidence has showed that the agroecosystem resilience against the pests is increased, so much so that the use of insecticides can be minimized. I believe there will be speakers that will talk about host plant resistance later, so I will not touch that. but I'll try to touch a bit more on all of the rest of this letter, if you will. So first, talking about monitoring, there is FAO has an app called Famous, of course, like everything else, we have an app for that. And Famous is, oh yeah, the name is interesting. It's a Armyworm monitoring and early warning system. Unfortunately, right now it's only Android based. So if you have an iPhone, it may not work very, very well. You can download this. It allows you to enter data on field scouting as well as trapping if you have traps. And then the data got lodged into our global platform, and it's helping some of our collaborators, including some of our in-house scientists, to do modeling for outbreaks. The app at the moment is experiencing a bit of a downtime, unfortunately. You can still download it and you can still upload the data, but it didn't go through very smoothly into the global platform. We're working to fix this. The Famous team was telling me this as they know that I'm going to give this talk, just as a to put it out there. But it's out there, and we'll be able to fix this hopefully in shortly. On good agronomic practices and conservation of biocontrol, these are a number of interventions that we've been looking at through the global IPM assessment. You can see the effectiveness, the scalability, and the strength of scientific evidences. So basically, things like balanced fertilization, using organic and inorganic fertilizer, that works. That works by sprucing up, plant health and the ability of the plant to compensate for damage. Minimum tillage, mulching, there's moderate to high level of effectiveness. Intercropping can also work both in terms of push-pull by interfering with the pest ecology, but also, depending on the plant that you use, increasing plant health. I would like to mention field margins for conservation biological control. This is something that is found to be highly effective. The scalability at the moment is region dependent. In some parts, it may be easier to scale than in others. But I would argue that a lot of this is dependent on education and perhaps incentives for farmers to adopt such method. Biological control is hugely important. There are over 30 parasitoid and predator species already found native in Africa and Asia. There are some mass rearing and mass releases being tested across the region, and over 15 biopesticide options show to be promising. There's a paper that we helped fund by Paul Jepson in Lancet Planetary Health. I would recommend everybody here to check it on minimum pesticide list for fall armyworm control. By minimum, Paul basically tried to argue that there must be a way in which we can classify the different pesticides to sort of minimize the risks of pesticide use. And he classified all of these pesticides based on their toxicity, their risks, if you will, both for human health and also for environment, and their efficacy. So this last row, if you will, are of the lowest risks for human health and environment, and the one on the rightmost column are the most efficacious. And what you can see there is that over 50% of the of the active ingredients in their sweet spot, if you will, are biopesticides. Surprise, surprise. But also some reduced risk pesticides such as chlorantraniliprole and methoxyphenoxide. The Achilles heel, I would argue, is twofold in terms of the use of pesticide. One is economic thresholds. We all know that it's highly dependent on the variety, because each variety has a different damage relationship to fall armyworm populations, but also to plant and environmental health. Is it stressed? Is it the plant health in terms of nutrition, in terms of drought stress and whatnot, but also on the levels of natural enemies. The second one is, if we are to be honest, economic threshold is highly dependent on local farm gate price and the cost of intervention. And thus, it is actually sort of impossible to calculate a global economic threshold, if you will, for a pest, because the prices differ with countries and even within countries. So as such, economic threshold should be highly localized, or at least calculated in regional or national level. And this information need to be made available for farmers. I would argue that this is an opportunity for ESI members to contribute in a very significant way to the global action by researching what is really the economic threshold for the use of pesticides against for armyworm, taking into account levels of natural enemies, for example, and also farm gate prices. The second one is insecticide resistance management. There has been a couple of papers that are published lately showing that there is evidences for resistance against organophosphate and some pyrethroids in fall armyworm populations collected in Asia. This is an example of a project that we have in India that shows that really the use of IPM by minimizing the use of conventional pesticide is possible by leaning on microbial inoculants, mulching, conservation, biological control, diversity, increasing diversity in the farm and landscape level, and the use of biopesticides. The general challenges, though, of using biopesticide is quite a number, really. It is one of the fastest growing industry globally, but it's still relatively low. There is a problem with registration capacity. Different countries have different capacities in registering biopesticides. There's a problem with availability and accessibility. So there is a need to increase the capacity for local producers and also logistical chain. And lastly, there's a problem with farmers' capacity for proper use of biopesticides. So here again, I would argue that there is a huge opportunity for members of ESI to contribute in filling up all of these gaps in the country. That's what I have. I hope I haven't taken too much over time. So thank you so much again for having me here, and happy anniversary for ESI. Happy to engage with questions if there is any later. Thanks.
Thank you, Pak Hadi. Well, you just you passed the limit. It's okay. Our next speaker is Dr. Govin Gujar. But before I introduce Dr. Gujar, I would like to remind for all of the participants, please write your question at the chat room, and please identify yourself and specify who you are directing your question. Okay, and then for our next speaker is Dr. Govin Gujar. Welcome to seminar, Dr. Gujar. We are very happy to have you here. Dr. Gujar received his education from Indian Agricultural Research Institute in New Delhi, India, and he also has a postdoctoral experience at Marie Curie in Europe. His experience and position include as a researcher at the SABC, South Asia Biotechnology Center, New Delhi, India. He was also the head of the Division of Entomology at ICAR, Indian Agricultural Research Institute, New Delhi, India. His research collaboration includes social ecological governance of resistance evolution with the Maryland Socio-Environmental Sciences Center in Annapolis, USA. Dr. Gujar research interests include the protein turnover in hemolymph of desert locusts, also insect resistant management, including Bt toxin, Bacillus thuringiensis, also insect resistant transgenic crops, genetic modified risk assessment, integrated pest management, safeguarding agriculture and farmer against fall armyworm. And currently, Dr. Gujar is collaborating with our friend, Pak Andi Trisiono of Gajah Mada University. They are writing a book titled Genetically Modified Crop in Asia Pacific. So Dr. Gujar, you will have 20 minutes to present your slide. Welcome. Thank you.
Hello. Hello.
Yes, sir. Could you please slideshow?
Yeah, just a minute. Yeah, I'm trying to share my screen. Okay. All right. Good morning to you all. Thank you very much for this invitation, and congratulations to Entomological Society of Indonesia. It's my great pleasure to be associated with this to your very esteemed society and the webinar that you are conducting today. We in India have been working with fall armyworm, and especially on the outreach program of fall armyworm. And in India, we grow maize on about 8 to 9 million hectare, and maize is an important crop in India. So is the case with many other countries like China, Philippines, Indonesia, Vietnam, and many other Asian countries and South Asian countries. As far as Asian countries is concerned, the import of maize within Asian countries is far more than what is the production is in Asian countries. So the production of maize is less than the requirement of the countries. And here is a slide that shows how the production differs in different Asian countries. China and Indonesia are two countries which have a high yields as compared to the rest of the countries in Asia. In India also we have, in fact in India the average yield is about 2.7 ton to 3 ton per hectare. And over the last 3 quinquennial years, the yield trends shows that the yields are going down. There is not much scope for increasing area, but there is a scope for increasing the productivity and increasing the production. But then the growth rates, as it appears over the last 15 years, are going down. Here is another example, studies that was carried out that shows that within India, there is a lot of variation, and there are some states, some provinces that produce as much as the developed country on per hectare basis. Like some of these countries, some of these states like Andhra Pradesh and Tamil Nadu produce how much better yield, more than 4 tons per hectare or more than 5 tons per hectare as compared to the others. The reason is that the maize crop is grown most of the time during the rainy season, and it is grown on a marginal lands and grown by most of the marginal and small farm holders which do not have capacity to invest in the agriculture technology. This table gives you an idea of how the technology can make the difference. This if you look at the technology used in terms of pesticide, fertilizer, percentage irrigation, and percentage hybrid seed, single cross hybrid seed or seed replacement ratio, you will find states which are producing more on per hectare basis also use the technology more than compared to those which are using which are having a less yield. So in a sense, it means that for the crop to yield more, you need to take care of the biotic and abiotic stresses that affect the yield component. Uh, con- Considering the fact that the biotic stresses are also important to us as an entomologist or as a crop protection scientist, in India, we have recorded around 250 insect pests and around 35 diseases. Of these biotic stresses, we find there are 2 to 3 insect pests more important and 1 or 2 diseases that regularly occur in maize crop. In other countries too, biotic stresses matter, and especially in China, Philippines, you have Asian corn borer, which is an important pest. Fortunately, this pest is not found in India. In Indonesia, you have shoot fly, Asian corn borer, you have weevils in storage, and other diseases too. Now, coming to now, in the last few years, we have been facing with another important insect, that is a fall armyworm. Fall armyworm is invasive to India, and like any other noxioid or lepidopteran insect, this insect yeah, has 4 stages, and here is a pictorial depiction of egg, larval, pupal, and adult stages. This information, biology of fall armyworm, has already been talked by Dr. Hari. This is some the pictorial depiction of how the larvae of fall armyworm damages the crop. The fall armyworm is native to South and Central America, and this pest is known to affect more than 80 plant species. There are some estimates that shows that fall armyworm is affecting more than 250 or 350 plant species. Now, even though the pest is polyphagous in nature, this shows a strong preference for some crops, especially maize as well as rice. And 2 strains of fall armyworms have been isolated in the United States and in Brazil. But the one strain that which we have and which have been studied and which we assume to be is a corn strain, and the hybrid of corn into rice strain that we have that has invaded the India in 2018. The fall armyworm, if you look at the fall armyworm travel, possibly at one time we thought that this has come from America, but then it appears to have, as far as India is concerned, it appears to have an origin from the eastern part of Africa based upon the studies carried out by Nagoshi et al. In 2019. Now, in India, we do not import much of the maize from Africa and also from the developed countries like USA. Little bit imports are really insignificant. So it just appears that the possibility of fall armyworm coming to India is through the stowaways in the passenger planes or through the wind from the migrations. And it is well known, as Hari has also said, that fall armyworm has a very good flight range. It is reported that the adults can fly a distance of around 100 kilometer or more than 100 kilometer over a night. And because of the wide host range and the multiple generation in a year, this pest can survive in many other places. Since 2018, when we had this pest, we have been monitoring it, and we found that this fall armyworm has spread in 2018, 2019, not only to India, but to Bangladesh, Sri Lanka, Myanmar, Thailand, China, Cambodia. By 2018 end, we did not have any report from Nepal, Pakistan, Indonesia, and Philippines. But now I understand that even fall armyworm has been reported from these countries also. A survey that I carried out a few days back also showed fall armyworm has been reported from Australia. It has been reported from South Korea too. So almost in every maize growing country of importance or even unimportant maize growing countries, fall armyworm, like, you know, maize is grown very insignificantly in Australia, and Australia is an island country. Yet there is a presence of fall armyworm in that country also. So the spread of fall armyworm is far and wide all over the Asia. Now, uh, there are some estimates that have come to my notice also, just like Hardy has informed, and these estimates runs into millions of dollars. In India also, we had some estimates done on various crop wherever fall armyworm attacked maize crop. But most of these estimates are guesstimates too, because they were based upon the newspaper reports and the reports that the farmers pursued of the damage that was caused. So it is very difficult to say how much is exact uh, uh, loss of the maize or how much is the loss in terms of monetary value. But then in India, if you look at the map of India, fall armyworm appears to be have spread right from South India to North India to Northeast part of the India. And almost all over India, we have been growing maize. Most of our production comes from the peninsular India during Kharif season or during Rabi season, and 70 and 30 to 25 to 30% production comes from the winter or Rabi season. There are some estimates that I worked out, and in 2018 Kharif, we suffered a loss of around $27 million because of the fall armyworm. Now, in 2019, there were some reports of fall armyworm, but not that many as in 2018. And in 2020, we had very few reports. Probably these reports were there in a local newspaper, but then the news coverage may not be there. So it's just likely that fall armyworm is either getting established in a very as if it is a native place, native pest, and the damage may not be perceptible as pursued earlier in 2018. Now, I was trying to calculate if fall armyworm is having an impact at a national level, and these studies that shows that up to 2018, a growth rate of of maize crop in terms of area was 0.3. In terms of yield, over the last 5 years was 0.6, and production was 1. Now, CAGR rate shows that the area over the last few years is not increasing much, only the yields are increasing, and it adds up to the technology used to some extent that we are able to make up for the more of the production. If you look at the effect of production in 2019, that effect should have been seen as a result of fall armyworm. But then it doesn't seem to be so. Yes, in fall armyworm, impact was seen in terms of lower acreage in 2019. We had 9.2 million hectare in 2018. In 2019, because of fear psychosis, the acreage has gone down to 8.2. Almost 1 million hectare was down. But in terms of total production, the productivity increased by more than 2 million tons in that year. And as if we look at the reports for 2020, the report shows that 2020 maize production will be in the range of 27 to 28 million ton with the area of around 8.5 million hectare. Now, this shows that at national level, fall armyworm did not make any impact. Okay, it could be because of also a fact that maize was being grown in the areas which were not be traditional. So it is likely that the maize crop escaped the fall armyworm attack in some of these areas, or the areas where the maize or in the areas maize was grown in less quantum as compared into the past. So the at national level probably it's not so. But then if you look at the other countries, if you will find that the story is almost same. Like in China, which is growing maize on about 40 to 42 million hectare and produces about 100 million tons. The area growth rate in area is just coming down there also. Only the yields are better. In India, same story. The area expansion is not taking place, but yield, it is only the technology that is helping to increase the yield. Unfortunately, both the countries are not using the genetically modified technology, and where this technology is being used, such as in the country like US, Brazil, Argentina, the productivity is high. It's, I do not mean to say that only one technology is making an impact, but definitely that each technology has its own proportion of impact, which is it has its own contribution to make to the total production. And if one goes by the reports, a recent report, Brazil and Argentina have overtaken the United States in the export of maize. And it's only because of the high production or high productivity in those countries. Now, insecticides are one area on which everybody relies on, and they feel that it is the only way you can control the insect pest. And fall armyworm control in my country and in many other countries is mainly through the insecticide. But then insecticide usage has its own problem. And if you look at this website or the fall armyworm resistance report, it shows that as many as 143 cases of fall armyworm resistance to insecticide have been reported until now. Sorry, until now means 2019. I don't mean 2020. That was done I did this survey last year. Now, and as many as 52 cases of field level resistance were reported all over the world, especially in the countries like Brazil, Argentina, and USA. Uh, Practically, fall armyworm has shown resistance to not only conventional insecticide, but to the insecticides such as the insect growth regulator or chitin synthesis inhibitor or the novel insecticide, which are like chloride channel modulators, or even the cryotoxins also. So there are some reports that the fall armyworm has shown the resistance to gene cotton too. But the there are no field level resistance reports till now. Yeah. So next is in our country, we are exploring the use of biological control agents, and these are some of the biological control agents which are reported by my colleagues in India. About dozen parasitoids.
Excuse me,
About
Dr. Gujar,
yeah,
can you?
time,
Okay,
time.
yeah.
Okay, yeah, about dozen parasitoids, predator parasites and microbials have been reported. Bacillus thuringiensis has been tried in some places, but then this BT strain has been reported to be very effective in China. The pheromone traps are being used for monitoring the fall armyworm. And one report that I came across shows that with pheromone usage and priming it with the insecticide use, you can bring down the losses to the extent of around 20 to 30% in maize. Now, studies which we have carried out in this country were on the relative efficacy of insecticide, both under laboratory condition and under field condition. And insecticides, on the basis of these studies and the earlier studies carried out elsewhere, the government of India has approved some insecticide for use. But most of our stays is following the integrated pest management, or during the time when the pest incidence is very less, we are emphasizing the need for the interventions such as using biological control measures or agronomic practices. With this, I come to the researchable issues, and we still feel that some of these researchable issues are important, like pest monitoring and pest forewarning system, and using the insecticide as a component of integrated pest management. Some work has been done in our country on evaluation of genetically modified maize, but this genetically modified or BT maize is not approved in this country. With this, I thank you all for giving me a patient hearing. And my colleague, Dr. Bhagirat Chaudhary, will talk about more on the outreach program that we have carried out for control of fall armyworm. Thank you very much.
Thank you, Dr. Gujar. It is unfortunate that we have to limit the time, but it was
No
very,
problem.
very informative. And I have the impression that India, I think, is doing okay in dealing with the FIA. Again, I would like to remind all the participants, if you have question, please write the question at the chatting room. Okay, for the next speaker is Dr. Bhagirat Hudori. He is also from India. Dr. Hudori is the founder director of South Asia Biotechnology Center in New Delhi, India. He is also serving on the board of the Agriculture and Processed Food Products Export Development Authority of the Ministry of Commerce and Industry in India. Also, he is the director of EFG India Limited at Mumbai. Dr. Hudori received his education from Maharana Pratap University of Agriculture and Technology at Udaipur, India. Also from the Department of Molecular Biotechnology, Faculty of Bioscience Engineering, Ghent University, Belgium. His research interests, among other, are creating and enabling ecosystem for technological and food production system, integrated pest management of invasive pests such as fall armyworm and locusts, and transfer of bio innovation from lab to the land for growth prospect for the bioeconomics. And Dr. Kudari will soon present his slide. Welcome, Dr. Kudari. You will have 20 minutes to present your slide. Thank you.
Thank you very much. Can you hear me?
Yes, very clear.
Thank you. So, before I begin my speech, I just want to refer to a couple of important messages. So the first one is that, I'm traveling, so I would request the organizer to really run on my slides. But I would actually seek permission from the chair, moderator, that I would actually refer to only very few slides, and I would like to talk to participant directly and not to really slides. I want to talk to you guys. Yeah, not
you are
to
welcome.
slides.
You are welcome.
Thank you so much. The third message is, yesterday I was really happy to receive a video message, a message where I got a video with the Petri dish full of insect fall armyworm larva, 6 stage instar, from a colleague from Indonesia. I don't know him. I just received a surprise WhatsApp message saying that, this is I have, and how do I control this particular caterpillar? I had no solution for him, because at that stage of this particular pest, it is very difficult to control. So that's how the social media, that's how the digital technology is helping us to connect and helping us to really share messages among people who are really concerned about food production and the problem related to invasive pest and transboundary pest. So I would like to, first of all, before I begin, this is the slide that you can actually run, but this is the Petri dish with these larvae that I received from Indonesian colleague. So before I actually really begin my talk, I want to actually thank Entomological Society of Indonesia for organizing this incredible program on integrated pest management of Spodoptera frugiperda. This webinar, I believe, is a true recognition of the fact that the scientific understanding and a pursuit for science-based integrated pest management is key to deal with invasive pests like fall armyworm. For last many years, a decade, I have extensive experience at field level to deal with pests like the Pectinoptera, the pink bollworm of cotton, Spodoptera frugiperda for last 2 years. And also this year, we had massive problem with a pest called locust, which actually invaded the western part of India, where I actually worked very closely with the department people to help farmer deal with this particular transboundary pest. I see this webinar as a tribute to twin objectives, and I want to congratulate the president and also the organizers that they actually put together this webinar, because it's not simply that you are celebrating the 50th anniversary of the society, but I think this is the first seminar that I believe is an important milestone in recognizing the fact that FAO is actually celebrating 2020 as an International Year of Plant Health. I think that's very important, and a seminar like this would be an important step to recognize what Indonesia, in collaboration with other neighboring countries, is doing to help farmers deal with these invasive pests. I believe 2020, we haven't seen much activities on plant health, simply because we've forgotten the aspects of plant health because of the pandemic of human health caused by COVID-19. But I believe a seminar like this is an important area that FAO should recognize and help farming community deal with problems that we are facing with pests like fall armyworm. I would like to also offer my sincere greetings to the president, the office bearer, and the member of scientific fraternity of Indonesian Entomological Society for inviting Dr. Gujar and myself of the South Asia Biotechnology Center to participate in this program. I want to have special appreciation for Dr. Devi Satyani. We never met. We are a WhatsApp friend, but thank you very much for allowing us to share our experiences dealing with this particular pest. I also want to acknowledge the support that we received from FMC Corporation to a massive project that we run in India called Project Safal. Now it stands for Safeguarding Agriculture and Farmers Against Fall Armyworm for last 2 years. And I think that project actually led to the successful management of fall armyworm in India. And I believe, that the management aspect is a testament of the resilience of farming community. And it also a testament of the functional nationwide extension system that we had, and a true model of public-private partnership in agriculture extension system. And I think, I want to highlight a particular aspect of the project, that the acronym SAFAL, SAFFAL, actually became familiar with the stakeholder, particularly with the farmer, simply because it meant success. SAFAL meant success in the lingua franca Hindi. And farming community were able to actually relate to this particular projects and the packages of practices that we shared with them, and they adopted it on larger scale, which enable us to manage this particular pest. Now, I just want to highlight, some of the key aspects. Many of our speakers actually talked about Spodoptera frugiperda. Now, this is a very highly invasive pest. As you can see from my slides, in India, we used to have 3 important pests before actually the invasion of this particular new pest. We have a problem with Chilopartalis. There was a huge problem that India faced in the past, but we were able to manage that particular pest. We had a problem with Sisemia inferensis, also, as you can see on the right top corner. And we also had little problem with Spodoptera litura. These pests, India were able to manage. The farming community never faced very big challenges. Pesticide use was not very much in the country. The time when the story actually turned in May 2018, when Spodoptera frugiperda, as you can see at the bottom with the identification mark on the top of the head and the bottom of their abdomen, creating huge problem for the farming community in the first year of particular invasion. In 1920, immediately 1 year after the first reporting of this pest, the majority of southern Indian states, many people in Indonesia may not know India, but many of the southern Indian states like Karnataka, Andhra Pradesh, Telangana, and Tamil Nadu, which are the key corn producing state in the country, they reported massive losses as suggested by Dr. Govind Gujar. We reported losses close to 20 to 30%. In 2018-19, we also had a huge problem when the availability of maize also contracted, which resulted into spike in the prices of maize. 1 year after the infestation, India actually reported doubling of corn prices in 18-19 by end of the 2018-19 and early 1920, which actually created huge problem in terms of demand-supply imbalance. And also, government of India immediately started actually importing maize to meet the growing need of poultry, animal feed, and starch industry. But the situation actually changed drastically. Let me tell the people who are connected here, in 2019-20, as the pest became widespread, it became endemic to the country, and many of the aspects of the project that I'm going to deliberate upon help India to actually started more learning, ground-based learning about management of this particular pest. The project actually that we ran, Project Safal, it involved multi-pronged strategy based upon the available literature. And I want to acknowledge here the literature that we used from FAO, from CIMMYT, from USAID, and from Indian Council of Agriculture Research, Indian Institute of Maize Research, and many other institutions. I think we have a very solid body of global data and evidences that are available, which actually help us to deal with this particular pest. Now, the strategy that we involve, and here is the key point of the strategy that I would like to share with the participant, that the strategy involved actually generating useful information, it then allowing us to disseminate the knowledge that we generated on the pest diagnostics, the biology of the pest, and the management tactics where maize was extensively grown. So I'm actually talking to you about reaching out to larger number of states in the country, both in the central, the southern part, eastern and northern part of the country. Now, the first important element of the strategy was that the central government actually provided policy support, and I think it is very important for people from the policy level who are connected on this particular webinar, that the central government of India provided very big policy support by facilitating the approval of insecticide on contingency basis. I think this ad hoc approval, by the government of India was really a big guide for us to the management implementation of the management strategy. In the first 2 years, and I want to highlight these important aspects because it was part of the whole aspects of management, the government of India's Central Insecticide Board and Registration Committee actually approved half a dozen of insecticide. And I want to refer to those some of these insecticides which were approved on the basis of contingency. 3 molecules, the single molecule that were approved included chlorantraniliprole, which is being sold as Corazon. The second most important molecule that was approved was spinotoram. The third important, so these were the 2 new molecules. The third was the extension was given to a molecule called imamectin benzoate. So these were the 3 single molecules that were approved by the government of India, along with the 3 combination insecticides, including molecules such as chlorantraniliprole in combination with lambda-cyhalothrin, then imamectin benzoate in combination with lufrenuron, and imamectin benzoate in combinations with novaluron. Another aspect of the government contingency plan was to approve the chemical for the seed treatment. I think it is very important for the participant to understand that one of the most important part of the integrated pest management strategy is to provide farmers seeds which are treated with the combination of pesticide called cintraniliprole and thiamethoxam. This is made available to farming community. It was made mandatory to the seed companies to supply hybrid corn seed which are treated with cintraniliprole and thiamethoxam. As you know, our fellow friend from FAO was referring to very important aspects that this particular pest can be managed only at very early stage of the infestations. So we are actually talking about the window which is like the day of planting to the first 30 days of germination. So providing seeds which are treated seed is, I think, absolutely critical part of the integrated pest management that I think that Indonesia and other countries should refer to. There were many biological control and there was a lot of talk about biocontrol. There were many biocontrol products that were also approved by Government of India, including Metarhizium anispol, that became very important part of the whole integrated pest management strategy. We also had approval for Metarhizium raleigh. Also, the approval was granted for Bavaria bassiana, also for the Bacillus thuringiensis in the form of powder form, and the NPVs. So these were the additional biocontrol measures that were approved by Government of India. Now, this particular projects, as you see, a couple of slides that are being shared by me and here. The project Safal outreach strategy actually involved not only the print and digital media, but also direct face-to-face personal contacts with stakeholders in group meetings. We also, had provided the pest and crop-based knowledges to farmer during these meetings, and this strategy actually resulted in cascading information directly or indirectly to more than 500,000 farmers. So here I'm talking to you about this particular project reaching to 500,000 corn farmer of India in last 2 years. It was a mega exercise that we undertaken in the country. As a spin-off of the projects that we are doing, because 500,000 farmers are a fraction of, I think, almost 8 million farmers who grow corn in the country. I think as a spin-off, what we have seen is that the public and private sector institutions also carried out their own extension activities for fall armyworm management. And I want to here highlight the role played by the Indian Council of Agriculture Research, state agriculture universities, agriculture science centers that we have each in each district of the country, and also state agriculture department. So it was actually an integrated effort in the form of integrated pest management in collaborations with companies who are supplying seeds and pesticides, including FMC, Bayer, Corteva, and many other Indian pesticide companies. The one important point that here that I want to share with people is that the effort actually appealed to the different information delivery channel. The involvement, generating knowledge is not sufficient, but whether that knowledge would actually reach to the end user, in this case, the farming community. So I'm talking about the whole value chain system here. So what we have seen is that the whole delivery system was so supportive. And therefore, we actually reach out through mass media, customized information material, demonstrations. We had active helplines, social media, and maize expert network that we put together for the country. I believe, and I want to share with with the participant here, is that the active farmer engagement and their demonstrated efficiency in controlling exotic pest upon first instance of infestation showed the efficient relay of information. Indian farmer also exhibited the tendency to actively uptake information when relayed effectively through different channels, including the involvement of retailers, involvement of the agriculture students. And as you can see from these slides, we had massive gathering of corn farmer across India, taking different aspects of integrated pest management to them. Additionally, what we've done is that the regular assessment of the conditions through surveys also facilitate the adjustment of the recommendations, because it was the first year when this whole project was launched, and farmers were also wanted to know whether the recommendations that we provided is acceptable to them or not. So this particular extension strategy actually successfully addressed the farmers' informational need in a targeted manner, impacting positively the farmers' fear, and the farmer fear of this particular pest actually went down, and their confidence to manage this pest actually really grew up. The maize farmer, as I want to tell you, that also fine-tuned the strategy at local level whenever needed, and these efforts actually resulted in limiting the pest damage and implementing the pest management strategies and management program help India to achieve the target of producing corn at the highest production of 28.7 million tons in last year. Now, I would like to ask the operator to take me to slide number 16, where I would like to actually share with you what the key aspects of this management strategy that we put together. So, as you can see from this particular slide, we actually divided the whole IPM into three bigger categories. The first was pre-planting, second was the post-planting, sowing and germination, and third was the post-harvesting. So if you really look at the pre-planting strategy that we put together, here you are looking at clean cultivation as one of the important area of the whole corn production system in the country. So we tend to actually popularize these concepts of use of weedicides so that you reduce the weed population at the time of sowing, thereby helping farmers to ensure that only corn is planted and you effectively control the weed, and thereby you are limiting the pest population or the emergence of the pest in that particular the field. The second important part was adoption of good agriculture practices by the local institutions, produced by the local institutions. And here we talked about timely sowing, the synchronized sowing, so that the corn, since these are hybrid corn, they grow very vigorously, can help to abate the whole the pest population. The third important element was the seed treatment, as I highlighted, the treatment of the seed through cyantraniliprole and thiamethoxam. I think it became very critical elements in the whole integrated pest management strategy that we put together in the country. The third aspect that we actually popularized was to install pheromone trap. Many farmers who actually never seen pheromone trap in their field because they never had a problem of pest at very early stage of growth of the corn. So we popularized the aspects of use of pheromone trap, the 4 to 5 pheromone in 1 acre. That means 10 to 12 pheromone per hectare was advised to the farmer to install at the time of germination of the seeds, so that you actually, since you have a problem with determining the ETL of this particular pest, as highlighted by FAO in the first seminar, in the first presentation, here farmer actually putting together pheromone trap allowed farmer to actually look at the beginning of the infestation, and then they can actually put together the control measures, including biocontrol at very early stage of this particular pest. And by doing this, we've seen massive monitoring exercise taking place across India under the aegis of Indian Institute of Maize Research. The another aspects, very small one, but very critical for farming community, is that we advise them to erect the bird perches at very early stage of germinations, so that the birds can come, the seed, and they can actually then, help them to, pick up the pest at very early stage and help them to reduce the pest populations. The second, the post-planting strategy that we recommended was to use both the combination of biocontrol when the pest is monitored at very early stage. We are talking about first to third instar larva. So if the pest is being identified or being monitored or being seen in the field at very early stage, from first to third instars, the massive recommendation of biocontrol that I suggested in my talk about the Beveria bassiana or the Metrorhizium really were distributed among farmers through state agriculture industries. If the pest actually is being seen at a very late stage, like the fourth, fifth instars or at the caterpillar level, we advise farmer to go for pesticide applications, those pesticides which were approved by government of India. And that strategy, actually, the combination of biocontrol at very early stage and use of pesticide at the fully developed larval stage, help really us to control the pest population in field conditions. In addition to this, we advise farmer that when they've seen the pest damaging the corn cob, I think the best way is to avoid use of any of the insecticide at that point of time, and advise farmer to remove those cob which are infested with this particular pest. That exercise actually had a lot of problem with the farming community, because they were not very much happy with this, that they're being asked to remove the cobs, which might reduce the level of the yield that they expect from the field. But we had and as of now, we have no way to actually help farmer to deal with this particular pest at the time of cob formation or at the time of cob development. And that's where I think one of the critical aspects of the whole strategy was to actually monitor and control pest in first 45 days of the crop growth. And I would recommend this to all the fellow colleagues from Indonesia who are into entomology, that any of the exercise on researchable issue that you are looking at, I think focusing on the first 40 days of the crop management and the pest management is absolutely critical to bountiful harvest of corn in the country. These are some of the points that I wanted to share. My slides also, last point that I want to share is that my slide also carries lots of different aspects of the program, where we actually came out with the specimens. We also came out with soft toys of the mimicking this particular pest to help farmer understand how they can differentiate this particular pest from the rest of the pest. These were some of the critical aspects. We have a forthcoming research paper on the Pan-India extension strategy, which is under review at this point of time, and we would be very happy to share any other aspects that you feel appropriate. Finally, I want to thank all the support that we received in India from our scientific and farmer fraternity, from the institutions that I listed here, and from FMC Corporation. Thank you so much.
Thank you, Dr. Khudari. Very interesting. I will summarize later on, maybe with some of them in Bahasa Indonesia. So before that, we will have our last speaker. And our last speaker is Dr. Pak Aditya Bagus Widiawan. Pak Aditya Bagus Widiawan. He received his bachelor degree. Excuse me, could you share the... Pak Bagus Widiawan received his bachelor degree in agronomy and crop science from Bogor Agriculture University, graduated in 2007. His experience and position: he is a market development officer at DuPont from 2007 to 2009, and then field biologist at DuPont from 2009 to 2012, field development executive for DuPont crop protection from 2009 to present. He is an integrated field science leader for South ASEAN Corteva Agri-Science from 2018 to present. Also, Pak Aditya received a certificate from Sustainable Rice Platform as a authorized trainer and basic remote pilot training. It's very wonderful. And his publication, among other, is rice brown planthopper baseline susceptibility to the new insecticide triflumesopirin in East Java. And Pak Aditya, you will have 20 minutes for the presentation. I would like to inform to all of us, we are a few minutes behind of our schedule, but that's fine. Okay, welcome, Pak Aditya.
Thank you, Professor Hamim. So I wanted to share my screen. Okay, I believe you can see my screen. Okay. Good morning, ladies and gentlemen, my fellow entomologists, expert and researcher with whom I respect to. Allow me to introduce myself. My name is Aditya Bagus Widiawan, and I would like to show my gratitude that all of you giving me the opportunity to talk about the strategy on corn, fall armyworm, from the perspective of corn seed industry. So, okay, let's start to talk about corn. When we look at the data on productivity of 3 major crops in Indonesia and focusing on the index of productivity on corn from 2005 to 2014, we found out that it has increased 42%, surpassing rice and soybean, while in contrary, maize is second only to rice in terms of planted area and also somehow government concern. The terminology here that of focusing on productivity, it is a combination of environmental potency, soil, water, air, weather, and etc., and human touch, whether it is farmer, breeders, seed producer, researcher who expert in agriculture, and other stakeholders as well. Productivity is a reflection of growing environment and human intervention. It is unique why corn is higher in terms of productivity when we compare to rice and soybean. Corn is a cross-pollinated crop, hence it is possible for hybridization, and this characteristic in which hybridization require to use the new seed create the seed industry and its supporting sectors such as breeding, production, farmer assistance, and etc. And when farmers experiencing consistency in terms of yield, when they use hybrid seed, again, they will use the same. And when we talk about corn seed industry in Indonesia, for instance, it is hybrid corn. And with the potential on yield increment 20 to 200% when compared to non-hybrid, it has become farmer choice, as we should remember that farmers is a business person who always calculate the input versus the output. Hybridization is a key to corn seed industry, and please bear in mind that hybrid doesn't mean it cannot be replanted. Yes, it can, it is possible. However, there will be a potential yield decremental or yield decreasing ranging from 25% to 75%, because hybridization is subject to the law of Mendel, the law of segregation. And the needs for new seed industry, which will be used in corn cultivation, will encourage the growth of seed industry, and it's not always related to the seed company itself or retailers or business whatsoever, but also other stakeholders, which came from professional background, such as researcher or expert. Farmers as a profession, they think logically, and they always calculate. They wanted to put minimum input with optimum output. For instance, though they are able to plant using harvested seed, but if they calculated that they can get improved yield, consistent result using new seed, they will choose to do so. And the need for purchasing new seed is becoming an incentive for breeders and the seed industry to innovate, and in addition to that, to create opportunity for researchers to develop new varieties. And please be considered that we need to feed a growing population of human beings with decreasing land acreage and high land use change. Again, productivity is important here, and innovation is one important component to improve the productivity. When we talk about corn, hybridization is crossing two parents within the same genus to produce or to generate a better individual. It is the evolution from conventional breeding, and it is not the same with the transgenic, where transgenic is involving insertion of genes from different genus into an individual, although both they share the same purpose to create better organism and both are parts in plant breeding. It is also science and innovation that will always lead to improving productivity. Now let's talk about the hybrid corn seed industry with around 4 to 6 million hectare of corn planting area in Indonesia, with let's say 50 kg seed required for 1 hectare. There will be around 60,000 tons of potential seed, which lead to hybrid corn seed industry. Though currently the market for hybrid corn seed is around 30 to 40,000 tons, and 60% of the market was run by the private seed industry, both MNC and local, using the proprietary hybrid. Meanwhile, 25% by the state-owned enterprise, and 50% round number by medium producer using public hybrid variety released by the IRD. Continuing previous slide, three components of the R&D, seed production, and marketing and mentoring. In R&D itself, there are product concept, breeding, variety release, cultivation tech, and demo plot. In seed production, there are parent staggering, partner breeder, detasseling, while in marketing and mentoring, we're talking about besides the promotional activities in related to business, farmer assistant is important things to be focused on for us as stakeholder in this business, while we also need to build a robust relationship with other stakeholders. So three of them are closely connected and influence each other. It cannot withstand or stand alone. Okay, we at Corteva, we are offering the integrated and sustainable way for fall armyworm management, because our ultimate goal is protecting the yield from the farmers. Corteva AgriScience has been a humble partner to the corn farmers, who have been one of the most resilient and productive farming community in realizing high yields and adoption of the technology. With the invasion of fall armyworm in Asia, there are additional challenges in managing this global pest. Armed with experiences from multiple countries where we operate on managing fall armyworm, Corteva AgriScience strongly believe that fall control is most efficient when using integrated pest management approach. And one of the most important components of fall armyworm management will be an integrated solution equipped with the seed apply technology, crop protection, as well as biotech trade. And our focus on protecting farmers' yield using these new technological and integrated approaches. We committed to provide complete solution to our growers, farmers, and expanded the choices that they can pick on and provide greater value. Both from seed and crop protection perspective, this will be involving the breeding, biotech, and digital solution. I will elaborate more in digital solution that we adopt here. It is the advancing technology in farming, such as using the AI or artificial intelligence, remote sensing, satellite imagery, or drone, and also the agronomic solution. And last but not least is the crop protection and seed apply technology, or SAT. Corteva AgriScience, we try to solve grower, farmers, or customer challenges with broader products and service offerings. We have set 14 of 2013 sustainability goal in 4 areas: commitment for farmers, the land, for communities, and in our operation that span across the globe and across our entire businesses. Employee-led committees develop this goal and plans to implement them. Input from external stakeholders, for sure, including farmers, was also incorporated. This goal reflects our company's size and scope, total focus on agriculture, and deep on farm relationship as well. And they activate the passion and expertise of our people, products, partnership to enrich lives and our planet for generations to come. This is the message that we would like to emphasize, because the way we operate is always focused on sustainability. Corteva AgriScience, with the pioneer brand seed that most of us here already know, is driving productivity for our growers with 90 years of plant breeding, driving genetic gain as well. In this slide, I will a little bit explaining about how we protect yield from the perspective of crop protection. With the emerging fall infestation throughout Asia, our farmers definitely wanted quick and fast solution to manage the ferocious pest. Of course, one of the tools that we can utilize here is the crop protection product. And Corteva AgriScience believe in the principle of sustainability, focusing on environmental stewardship, while we can keep how effective the product to manage the fall armyworm. The integrated solution approach which Corteva provide here is involving the seed apply technology, involving crop protection product and seed genetic and traits as a holistic approach for fall armyworm management. Let's start to look at our SAT, or seed apply technology product, the first insecticide seed treatment with the technology of using chlorantraniliprol, the group 28 diamide molecule with WHO green label. And having this seed apply technology can protect from early infestation of fall, will bring peace of mind to the farmers, completed with the excellent toxicological profile and worker safety profile, also having low to no adverse impact on beneficial invertebrates and pollinator, and while keeping its broad compatibility with other commercial available SAT. It has been registered in many countries for fall armyworm management, including US, Brazil, Argentina, China, Thailand, as well as conditional approval in the Philippines and on progress to be registered in Indonesia. Now let's jump to our Spinotheram. It is our Green Chemistry Award-winning molecules that is produced by Saccharopolyspora spinosa through fermentation. The one and only manufacturing process for Spinotheram is located on Harbor Beach, Michigan, with the state-of-the-art technology involving AI to control environmental supply of nutrition, water, and everything to produce the Spinotheram. And fall under spinosyn class of group 5, IREC MOA, it will be an excellent rotation partner with another MOA exists on the market. And Spinotheram also effective against fall armyworm with contact and ingestion activity with favorable ecotox profile. It is easy on natural enemies, hence it is an ideal partner for other IPM-based tactics. Already registered on many countries across AP, including Indonesia, the Philippines, Vietnam, Thailand, and Malaysia. This slide explaining about the progression of our trades or biotech is after we talking about the seed applied technology and then spinotherum as a solution for foliar. We talk about the how we progress with the biotech seed in ASEAN. In this case, the Philippines is becoming the advanced countries amongst ASEAN country with regard to biotech. So I'm taking an example here, the Philippines. It started from 2004 with Cry1AB, and we are looking forward for 2022 with PowerCore, the stack BT and combination of 3 BT proteins to provide broad spectrum control of the most economically important Lepidopteran pests, included here for sure the fall armyworm. The PowerCore here express the BT protein of Cry1FA, Cry1A.105, Cray2AB2, with the Cry is the stand for crystalline, the protein that have insecticidal activity on some insect produced by the soil bacterium Bacillus thuringiensis. This slide show the most economically important Lepidopteran on corn, ACB, the black cutworm, corn earworm, and for sure for armyworm. This is the picture of the comparison of corn equipped with the biotech traits on the right side of the picture and the non-biotech one. It is under the same field infested by the occupied by the fall armyworm. And this slide show us about the efficacy of PowerCore on fall armyworm when we evaluate the leaf feeding injury using the scale from 0 to 9. This chart generated from the average 11 trial from 6 US state from 2008 to 2011 and has been submitted to the Journal of Economic Entomology number 107 in 2014. This is my last slide, and I'm proudly sharing that we at Corteva AgriScience is committed to engage by listening, learning, and sharing, and also actively involved in developing innovative tools. And for sure, we are always partnering globally and regionally to deliver integrated pest management solution. So thank you for your opportunity for me to giving my speech, and I will turn back to Prof. Hamim. Thank you for opportunity.
Thank you, Pak Aditya. Now it's time for the discussion. But before that, I would like to ask your permission for the participant who are not speaking in Bahasa Indonesia. I will present very short summary in Bahasa Indonesia. Bapak Ibu sekalian, tadi sudah kita ikuti bersama 4 presentasi yang sangat penting dan bagus sekali. Pertama dari Pak Buyung, pada intinya beliau menceritakan berbagai pengalamannya untuk solusi fall armyworm ya, melalui integrated pest management, melalui kegiatan monitoring. FAO juga memiliki aplikasi yang bisa diunduh walaupun pada saat ini sedang agak bermasalah. Kemudian Pak Buyung juga menekankan pentingnya good agronomics practices, biological control, pesticide application, ada minimum list di situ. Dan salah satunya juga tadi Bacillus thuringiensis. Tapi Pak Buyung juga menunjukkan beberapa kelemahan, Achilles heels istilahnya tadi, dalam bidang dalam economic threshold. Penerapan economic threshold itu mempunyai banyak dependensi dan oleh karena itu harus dilocalize. Nah, ini kesempatan yang baik untuk penelitian para calon master, calon doktor, karena economic threshold itu disarankan lebih lokal. Jadi kita tidak bisa mengadopsi begitu saja dari negara lain atau dari tempat lain. Kemudian yang berikutnya adalah Dr. Gujar. Beliau menceritakan pengalamannya menangani dalam membantu penanganan fall armyworm di India, dan saya mendapat kesan pada saat ini sudah bagus kondisinya. Bahkan pada tahun 2020 itu disampaikan sedikit laporan tentang serangan fall armyworm. Jadi ini salah satu keuntungan kita bisa belajar dari negara lain. Kemudian walaupun tadi juga dilaporkan sempat menyebabkan kehilangan hasil sampai 25%. Bahkan tahun 2018 itu menyebabkan kerugian 27 miliar itu juta ya, 27 juta US dollar di India, lumayan. Kemudian Pak Dr. Hudori from India banyak menyampaikan informasi yang sangat penting ya, dan salah satu tadi yang menurut saya patut kita cermati adalah anjurannya untuk melakukan monitoring dan kontrol on the first 40 days. Jadi 40 hari pertama sejak munculnya koloni. Ya, ini adalah timing yang sangat kritis. Nah, oleh karena itu pelatihan-pelatihan kepada petani itu perlu juga diberikan supaya bisa mengidentifikasi dan mendeteksi kapan koloni itu mulai muncul dan dilakukan pengendalian 40 hari sejak itu. Kemudian Pak Aditya menceritakan pengalaman-pengalaman dari Corteva ya, dalam berkontribusi untuk pengendalian fall armyworm. Ya, beberapa produk telah dihasilkan, spinetoram, powercore, dan juga tentang komitmennya untuk sampai 2030. Okay, that's about the summary of the talk that we have today. And I would like to, I have a list of questions from the participant. So I would like to read some of this. First question is from Ibu Rukmawati Brotojoyo. Ini untuk Pak Buyung. Tadi kalau sudah ada yang dibalas di chat, mungkin perlu disampaikan, tapi mungkin perlu juga tidak. Barangkali yang lain tidak mengikuti Pak Buyung. Oke. Pertanyaan, question from Ibu Rukmawati. Ya. How could we get the program to monitor FAW? Mungkin ini tentang aplikasi. Kemudian dari Pak Bakhtiar Yulianto, ini untuk Pak Buyung. Since the spreading of this pest from America, what action have been done to control this pest, particularly in America? Another question from Pak Didi. This is directed to Pak Buyung. The question is, beside pesticide to control fall armyworm on the field, as I know in Indonesia, the percentage level of severity of FAW on maize almost different for each hybrid. Do you have information about visual characteristic of maize we can reduce fall armyworm infection on the field? And there are 6 questions. And also question from Abel Jimenez from Timor-Leste. Lembaga karantina ini, quarantine and biosecurity in Timor-Leste. In Timor-Leste, we have done fall armyworm risk assessment supported by FAO. We found that fall armyworm was seriously impacted for corn plantation in Timor-Leste. So my question is, could you explain about biocontrol system for fall armyworm? My question directly to the speaker, to Pak Buyung. Another question for Pak Buyung is from Ibu Fariza of the Directorate General of Estate Crop. The question is the fall armyworm phenomenon related to climate change? How about its attack chance in estate crop? And another question, you have 6 questions for Pak Hadi. From Ibu Nafis Maisin, I'm not sure, Ibu, from Malaysia. This is a question from Malaysia. I'm not sure it's Ibu or Bapak. Could you please share about success assessment of fall armyworm IPM? Okay. Okay, Pak Buyung, could you answer those questions?
Sure thing. Thank you so
You
much.
don't have to answer all of them, but you can select which one is more representative.
Sure thing. So thank you so much for all of the questions. I've tried to answer most of them live through the chat. So if you like to just scroll down or up, as the case may be, you'll see the answer to most of those questions. So for example, the app Famous, it's an Android-based app, and you'll be able to see it in Google Play Store. And then there are also some other questions from Timor-Leste on biological control that I've already answered at length in the chat. I will not repeat them here, as well as the question on estate crops and climate change. So I've answered all of those there. I'll take 3 other questions here. The first one is what is done in the Americas for fall armyworm control. GM crops is the predominant way to manage fall armyworm, especially in North America. And in many parts of Central and South America as well. Having said that, countries, for example, like Embrapa, like Brazil, through Embrapa and their healthy biopesticide industry, has also been able to try and push biopesticide and mainstream it as a part of the solution for fall armyworm in Latin America. Besides pesticides, hybrid, correct? There are some data, not too many, but there are some data that are available out there that shows that generally some hybrids are able to overcompensate for the damage. I have not seen the published data, if you will, on this, but there are old data from CIMMYT, especially in Latin America, to show this that were published in 1990s. So this is something that we will still like to keep our minds open and would like to see the published data on this. There is a data on germplasm screening in South Africa. That is just published a couple of months ago, and I'll be able to put the paper, or at least the link to the paper, in the chat after this. One last one that I can tackle is a success on fall armyworm IPM. There are a number of successes. I'll put at least one of those that come from FAO in the chat right after this. So
okay, there is another question from Vietnam. Did you read that? Have you answered that?
I answered that as well in the chat.
Okay, okay. And there are also questions for Dr. Gujar and Dr. Kodwari. So the first one, I would like to read the question for Dr. Gujar. The question is from Ibu Sartiami from Bogor Agriculture University. The fall armyworm is moving around. Is there any information whether the fall armyworm population in India did come from neighboring countries or many countries? This is for Dr. Gujar. Please, you can answer that, Dr. Gujar.
Thank you very much.
Okay, before you answer that, there is another question. Let me read the second question for you.
Yeah.
I didn't read this on the. Okay, okay. This is the same question. I'm sorry, it's the same question, but type twice in the. Okay,
It's
you can
okay.
answer that.
Fine. Thank you very much. Thank you very much. There is one paper published by Nagoshi et al. In 2020 that shows that using mitochondrial DNA marker, the insect population seems to have come from Africa, and that belongs to C strain, and some to the hybrids of C and R strain. I hope this clears it.
Okay, thank you.
Yeah.
The next question is for Dr. Bagirat. I will read the question from Pak Yusuf Hidayat. He is from the University of Pajajaran. This is from West Java, Bandung. Are these special strategies currently implemented in India to minimize the effect of synthetic insecticide to the natural enemies of fall armyworm? That's the first question. And then the second question for Dr. Kudari is from Ibu Dewi Sartiami from Bogor Agriculture University. How about the role of university on extension as a SAFAL project? Is there any university involved in the project? I think that's all of the question for Dr. Khudari. Please, you answer, sir.
Yep. Thank you so much. So before I actually answer these two questions, I would like to share some of our experiences with the participant, that with relations to hybrid and pest infestation, what we noticed in India is that those hybrids that are supplied to farmer, which actually yield corn cob with tighter husk and the tip filling, are less likely to be damaged than those hybrids which are soft in husk and not actually filled to the tip of the corn cob. So what we have been doing for last 2 years is that we have been advocating companies and institutions to look into the breeding aspects of corn hybrids that are tighter in husk and that are actually can be filled to the tip of the cob. So this is a additional information to the question was raised to FAO representative. As regard to the strategy, as regard to the strategy on the fall armyworm management, Government of India has clearly came out with a package of practices that does not actually lay much emphasis on use of insecticides. I think it has clearly actually demarcated different windows of control measures, and much of the emphasis actually is laid on seed treatment and use of biocontrol. And what we have seen in last 2 years is that many institutions that used to produce less quantity of biocontrols like metarhizium, anispol, Relay, and Beauveria bassiana, BTs, NPVs, they have significantly increased the production system, and a lot more advisories being issued to use biocontrol at very early stage of the pest infestations. So I would like to repeat the monitoring aspects. The monitoring of the pest at very early stage is absolutely critical to control the pest and use the less amount of pesticide, which otherwise would be inevitable after the pest become, let's say, a mature pest. So IPM is a core to all the Government of India's strategy, including the Project Safal that we run. The last question is about the involvement of public sector institutions. I would like to inform the audience here is that This particular project actually involved 15 state agriculture universities, 45 KVKs. These are called agriculture science centers. And we had actually were collaborating with 1,000 agriculture scientists in the country, including entomologists, pathologists, agronomists, and crop protection, management, good agriculture management practices people. So this particular project actually is being implemented in collaborations with public sector institutions. And the 2 years of gains that we have seen is now with the public sector institutions, and we believe that a lot more activities is now being carried out by these institutions to take these IPM practices to the farming community. Thank you so much. Over to the moderator.
Unmute. Okay.
Okay, I'm sorry. I just lost the connection a few moments ago, but now it's reconnect. Thank you, Dr. Hudori. The next question is from my dear friend here, Pak Joko Priyono. Hello, Pak De Joko. How are you? The question from Pak Joko Priyono is for Pak Aditya. I could not find the registration of Spinotoram in Indonesia. Is it in progress? That's for Pak Aditya. And there are other questions for Pak Aditya from Pak Didi. He doesn't mention from what institution. Pak Aditya, how about the comparison of Lumifia with all chlorantraniliprol as treatment versus foliar to control for armyworm in corn? And there is another question. I think anybody can answer this. From Ibu Titik Darmadi. She is a former entomologist on tea plantation. As far as I know, that Bacillus thuringiensis has been used since 1977 or 1980 up to now. Is there any new strain of BT? Is there any resistance to the pest? Thank you. So first, I would ask Pak Aditya to answer the question from Pak Joko and Pak Didi. And the last question, I don't know, maybe Pak Buyong or Pak Kusyar. Okay, silakan Pak Aditya.
Thank you, Prof. Yeah, well, actually, I already answered to Pak Joko through the chat room, but I will repeat again that the Endure, if we see the label for the old product, maybe it's not updated yet because Endure is just registered last year, 2019, for controlling for armyworm. But then you can find in MOA decree number 103, 10, and 2020. So basically, we already registered for the Endure. Meanwhile, for the Lumifia is just under the process for registration, yeah, as a seed treatment. And also this will lead to Pak Didi question. Yeah, actually the way of working is a little bit different, Pak Didi. Lumifia will be applied to the seed, while the AI of chlorantraniliprol for non-Lumifia, because Lumifia is some kind of brand name, will be applied foliar. So the way of working of both will be different. But in terms of the ecotox profile, environmental profile, the target, the scope, and also the spectrum of control of Lepidopteran on both AI will remain the same. However, Lumifia is targeted on the seed. So it's protecting basically from the early vegetative phase. And besides for armyworm, based on our in-house or internal trials, we evaluated that it also suppressing the cutworm infestation somehow. But then cutworm is not as dominant pest that we found in Indonesia currently. Fall armyworm is the one who is dominant. So basically, the way of working of both it will be different, but everything is the same, like the label, the green label, the LD50, LC50, LD90, LC90 is all the same because it came from same mode of action, same AI, Pak Didik. Yeah.
Thank you, Pak Aditya.
Thank you, Pak Amin.
I always have trouble in spelling and pronouncing the Chlorantra. What the hell is that? Could you somebody please change the name?
It's all right. It's okay. It's
For the sake of everybody. Okay. I think we have
second part.
we have a very good discussion on the subject, and thank you very much for all the speaker. It's very useful information, and thank you for team in Bogor. And
Just
now
1 minute.
I would like to pass Pak Hujar. Okay, please.
Yeah. One clarification which I would like to give about the BT. Bacillus thuringiensis variety Kustaki, HD1, and Bacillus thuringiensis isaavi are known to be effective against Spodoptera, Spodoptera litura, Spodoptera fergiperda. But the level of efficacy requires a higher doses. And if you look at the work reported by G. Zhang of CAAS, Institute of Plant Protection, China, it shows that the amount of they have registered Bacillus thuringiensis, or they are registering the Bacillus thuringiensis for control of FAW, but the amount is relatively high. Number two, the next one question was related to the resistance in FAW. See, FAW is reported to have evolved resistance to the toxins like Cry1F and possibly to Cry1AB also. But field level resistance is not reported to BT maize. So there is a possibility that one can really use BT maize expressing Cry genes. This is all. I hope I'm clear to the questioner in this respect.
Thank you very much. Thank you very much. Well, this is a real pleasure for me to have all of you, and I would like to connect by other means, email or phone numbers. Just for your information, our team here in Lampung are testing mating disruptive pheromones from Provivi. We are conducting at 60 hectares. So we are observing on an area of corn about 60 hectares in Lampung. Thank you very much.
Thank you.
Bu Dewi, please take over from me. Thank you.
Thank you.
Kak ya. WK masih mute ya?
Okay.
Okay, ya.
Well, thank you very much, Prof. Hamim and all speakers. It was very interesting and useful discussion for all of us today to deal with Spodoptera frugiperda. And next agenda is certificate appreciation. Virtual certificate will be submitted by the President of Entomological Society of Indonesia. Prof. Dadang, please welcome.
Okay, thank you. The first certificate, yes, Pak Buyung, thank you very much. This is certificate for you. Thank you for sharing the very impressive presentation and also sharing the information.
Thank you, Pak Dadang.
Okay, yes.
Thank you.
This certificate for Dr. Gavin. Thank you very much. Very valuable information for us here. Yeah. Okay.
Thank you.
Yes, this is for the Dr. Bagiraj Kaudari. Thank you very much for your presentation today.
Thank you so much.
Okay. Then this for Mr. Aditya Bagus Suriawan. Thank you very much, Mas Adit. Good work, I think. Good Kortepa.
Thank you, Prof. Dadang.
Okay, yeah. Thank you. Okay, Bu Eka, please.
Thank you, Prof. Dadang. Finally, we arrive at the end of the agenda. But before closing, I have an announcement. Today is the deadline for collecting the insect photo contest and essay. So the committee will wait until 11:59 p.m. And ladies and gentlemen, from the deepest of my heart, I do apologize if there were mistakes. And thank you very much for kind attention and see you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.
Stay safe.
Oh, terima kasih Bu Eka.
Oke, terima kasih
Terima kasih,
semuanya.
Pak.
Sukses terus untuk PEI.